Hi guys, here we are in section 3.3, taking a look at problem number 10 from the book, part of tonight's homework. I thought I'd go over this problem for you just so you could see a scatter plot that I made, just so you could see. Also, I graphed it on the calculator just to remind you of how you can make these scatter plots on the calculator and find a line of best fit there. Probably haven't done that in a couple years, so it might be a good chance to review that. As we see here, that this application problem is about comparing hours without sleep of college students to the number of errors that they make on simple addition problems. So as you can see by my scatter plot that I made, the general trend appears to be the more hours that you go without sleep, the more errors that you're going to make on those problems. Makes sense. You need sleep to be a good student, and that's words to live by that we can all probably follow. So there's my scatter plot. The stars represent the points, and the green line is my line of best fit. Now this one doesn't really touch any of the points, but it does split the data in half pretty nicely. You can see that we have 1, 2, 3, 4, 5 points below the line, 1, 2, 3, 4, 5 points above the line. So that's a decent line of best fit. Even though it doesn't hit the lines, hit any of the dots, it actually goes, splits through the middle pretty nicely, I think. You might notice that down here in my graph, I did break the graph, so I skipped some points. So one thing to remember, when you see my line of best fit come down here like this and hit what appears to be the y-axis at 6, that's not really the y-axis. Keep in mind that since I started with a break in the graph, the actual y-axis would be further down the paper. So, in other words, what I'm saying is this is a misleading graph in that you might think that my y-intercept is going to be 6, which it's not. Keep that in mind for later. Now, to actually find the line of best fit equation, I'm just going to pick a couple of points that look pretty good here. Let's use the little smiley guys. Let's pick, how about 18, 12? That looks like a good point to use. And 10, 8. Using those points, 18, 12 and 10, 8. 18, 12. And then the other one is 10, 8. Let's go ahead and find the slope. The slope's going to be the difference in the y's on top, change in y, over the difference in the x's, change in x. If I subtract 12 minus 8, I get 4. If I subtract 18 minus 10, I get 8. So the slope appears to be 1/2. The slope of my line of best fit. So that what that means is, as we get fewer hours of sleep, it looks like the ratio is for every 1 hour without sleep. No, that's backwards. You make one more error for every 2 hours without sleep. Think about that. So you make. Let's look at it in terms of climbing up the ladder here. Let's start at this smiley face. You make 1 hour. You make one error for every 2 hours without sleep. One more error for every 2 hours without sleep. Up 1 over 2. Up 1 over 2. That's the rate of change. One error for every 2 hours without sleep. Okay, so that's our equation. Let's use point slope form since we do not, just kidding. Let's use, point slope form. Point slope form because we don't know what the y-intercept is. Point slope form. Y equals y1 plus b times x minus x1. If you're taking a look at this video at home with any parents, and parents remember the old y equals mx plus b, that's a little bit backwards now. M is no longer in use. We now use b as our slope. Just a little word of caution there. So let's use this point, 18, 12. 18 will be our x1. 12 will be our y1. Let's plug in 12 for y1. The slope that we found is 1/2. And then we have x minus our 18. If we distribute this, you're going to get 1/2 x minus half of 18 is 9. And if we combine like terms now, we get y equals 3 plus 1/2 x. 3 plus 1/2 x looks like the equation of our line. Y equals 3 plus 1/2 x. Line of best fit. Let's take a look at what we have up here. It says write an equation of the line. That's part B. We just did that. Y equals 3 plus 1/2 x. Based on your model, how many errors would you predict a person to make if she or he hadn't slept in 22 hours? Well, if we plug 22 in for x, that's a pretty easy calculation. We can handle that. Y equals 3 plus half of 22 hours without sleep. Half of 22 is 11. 11 plus 3 is 14 mistakes. 14 errors would be made by a person with 22 hours without sleep. In 10C, did we use interpolation or extrapolation? Those are two terms that you can find in your textbook. Interpolation is when you are calculating a value that's in between your data points. Extrapolation is when you go extra, let's say. Let's use that prefix extra from extrapolation. That would be more like what we did with the wave data when we predicted what would happen with 54 or 50 students in the wave. We used our data to predict beyond. That's extrapolation. Interpolation, inter, means that we were using the data to predict a value that's within our data points. Our data points went out to 24, and 22 was within that range. So interpolation is the answer for D, interpolation. That's it for now. If you'd like to go to the next video, I'm going to show you what this graph would look like on the graphing calculator. Didn't want the video to be too long, so it didn't take too long to upload and or download. So check out the next video for some calculator tips. Thank you.